Hi students, here I discuss some question related to the vapor pressures. Okay, so first question, sir, the vapor pressure of the benzene at 80 degrees centigrade is lowered by 10 mm when 2 gram of non-volatile substance is dissolved in a 78 gram of benzene. Vapor pressure of the pure benzene at 80 degrees centigrade is 750 millimeter, the molar mass of the non-volatile substance. Here this problem is related to the vapor pressure, relative lowering vapor pressure. So we know that formula, relative lowering vapor, according to Raoult's law, P naught minus P divided by P naught is equal to W2 divided by M2 into W1 into M1. Okay, this is the relative lowering vapor pressure. What is the question here? The vapor pressure of benzene at 80 degree is lowered by 10 millimeter. Means P naught minus P represents the lowering vapor pressure. What is the lowering vapor pressure here? 10. Okay, divided by when 2 gram of non-volatile substance dissolved in a 78 gram of benzene. What's the weight of the solute here? 2. Okay, and dissolved in a 78 gram of benzene. So 78 gram of benzene is a solvent. What's the weight of the solvent? The weight of the solvent is 78 gram. Next, vapor pressure pure benzene is a 750. So this is a 750. P naught is equal to 750. The molecular weight of the substance they can ask here. Okay, so M2 find out. M2. But M1 is the molecular weight of the solvent. Which is the solvent here? Benzene is a solvent because 2 gram non-volatile substance dissolved in a 78 gram of benzene. What's the molecular mass of benzene? 78. Okay, 78 is the molecular mass of the benzene, C6H6. So 78 cancelled here, sir. So then you simplify here, M2 is equal to M2, 2 into 750 divided by W divided by 10. So this is a cancelled here. 75 into 2, 150 gram. So 150 gram is the molecular weight of the solute. So that's why the first option is correct here. Okay, I go for next question, sir. So in the next question, sir, the vapor pressure of the solvent is 20, whereas that its a dilute solution is 17, or the mole fraction of the solvent. We know that according to the Raoult's law, relative lowering vapor pressure produced by the dissolving non-volatile solute is equal to the mole fraction of the solute. Mole fraction of the solute. Okay. Therefore, here vapor pressure of the solvent is 20. P naught is equal to 20, and whereas that a dilute solution is 17. This is a 17 divided by 20 is equal to x2. X2 means the mole fraction of the solute. So here 3 by 20 is equal to x2. If you simplify this one, 0 point equal to 30 means 1, 10 is remaining, 5 is equal to x2. This is the mole fraction of the solute. But they ask here mole fraction of the solvent. So but we know that x1 plus x2 is equal to 1. So here you want to find a mole fraction solvent, means x1 find out is equal to 1 minus x2. So 1 minus x2, 0.15 means the answer is 0.85 is the answer. Options third one is correct here. Okay, I can take next question. So next question, the molar elevation constant B for water is 0.52 Kelvin per m. 0.1 molar solution sodium chloride will be here. Molar elevation constant Kb. Molar Kb value given. Kb is equal to 0.52 is a given molar elevation constant. 0.1 molar solution sodium chloride will be boils at. So we know that the delta Tb is equal to m into Kb. It's a formula. Okay, or here sodium chloride completely dissociated, they form Na plus Cl minus. That's why I value, Van der factor I value 2. So here you consider I value. So otherwise I is I into m into kb. So okay, so I value 2. What is the m value? Molar solution 0.1 molar solution. So this one is a 0.52. Okay, this is a given. So first delta TB find out here. So otherwise this one you can written as here 52 into 2. Okay, into 10 to the power minus 3, correct? And this is 52, 10 to the power minus 2, this is a 10 to the power minus 3. So this means 4, 2 into 2, 4, 5, 104 into 10 to the power minus 3. So otherwise can written as 0.104 is correct. Okay, this is the delta TB. So but our questions here, boiling point of the questions here, solution, sodium chloride will be boiling point of the solution they ask. So we know that formula, delta TB is equal to T minus T naught, because the boiling point of the solution greater than that of the pure solvent. So delta TB, you know that 0.104, okay, then T find out, but we know that pure solvent, the boils at 100 degree centigrades. So that's why T is equal to 100 plus 0.104. That's answer is 100.104 is correct. So options fourth one is correct here. Okay. Next question. What is the weight of sodium chloride is added to 1 liter of water so that delta TF divided by KF is equal to 1 by 500. Question: what weight of sodium chloride is added to 1 liter of water? So you know that delta TF is equal to M into KF. This is the formula. But here sodium chloride, weight of sodium chloride they ask now. So sodium chloride NaCl dissociated as a Na plus and a Cl minus. That's why I value is equal to 2. So now I consider the Van der factor I is delta TF is equal to I into M into KF. Okay. So now I value is at 2. Okay, correct, 2. So M you find out molarity, but one point they given delta TF divided by KF. This value given. What this value? 1 by 500. So this is a 1 by 500 is equal to 2 into M. So M is equal to 1 by 1000. See here, molality get 1 by 1000 we get it. So what is the meaning of M is equal to 1 by 1000? Actually 1 by 1000 mole of solute present in 1000 gram solvent. Actually this is a given 1 liter water, because they consider density taken as 1. So density is equal to mass by volume. That's why if it consider density is 1, then it's correct, 1000 gram of solvent. So what is the mole of solute here? 1 by 1000. This is a mole of solute. So we know that mole formula, mole is equal to mass divided by molecular mass. Okay, what is a mole here? 1 by 1000 is equal to mass find out here. What's the molecular mass of sodium chloride? 58.5. It's the molecular mass of this one. Okay, so mass is a find out here. So mass is equal to 58.5 divided by 1000, or 58.5 into 10 to the power minus 3, or we can write this one 0.0585, because 10 to the power minus 4, so 1, 2, 3, 4, correct. So that's why options third one is a correct here. Okay, next problems. Okay, next one. An aqueous solution of glucose boils at a 100.10 degree centigrade. The molar elevation constant for water is 0.5 Kelvin kg per mole. The number of molecules of glucose in the solution contain 100 gram of water. Here, a aqueous solution of glucose boils at 100 point. The molar elevation constant for water is given. So delta TB is equal to, okay, molar elevation constant for water is given. So M into Kb. So here a glucose solution, this is aqueous solution, glucose boils at 100 degree. So now delta Tb find out first. Delta Tb is equal to T minus T naught. Difference between the boiling point of the solutions and a pure solvent is called elevation in the boiling point. Aqueous solution glucose boils at, okay, this is a glucose solution boils at 100.01 degree minus 100 degree, okay, 100. So answer is a 0.1. This is a delta Tb. So I substitute here 0.01 is equal to, this is a glucose solutions, okay, M into Kb. What is the Kb values given here? 0.5. Okay, this is 0.5. So now M is equal to 0.01 divided by 0.5. This one you can written as a 1 into 10 to the power minus 2. This one you can written as a 5 into 10 to the power minus 1. Correct now? So 1 by 5, 0.2 into 10 to the power minus 1. Correct now? 10 to the power minus 1. So you can written as 0.02. This is actually molality of the solutions. Okay. So now questions here. The number of molecules of glucose in the contain 100 gram of water, because 0.02 molality. What's the meaning of this one? 0.02 mole of solute present in 1000 gram solvent. 1000 gram solvent. This is the meaning of this one. 0.2 mole of solute present 1000 gram of solid. Therefore, my questions here, number of molecules, now first 100 gram. Therefore, the number of moles of solute in 100 gram first find out. Therefore, number of moles of solute in 100 gram solvent is equal to how much? Cross multiplication means we know that 0.02 mole present in 1000 gram. So 100 gram consists of how much? Cross multiplication is 100 into 0.02 divided by 1000. So 100 ones are, this is the tens are. Okay, this answer is 0.002 will be get it here. Mole. Okay, this is a mole. This number of molecules find out. So one formula you know that number of mole is equal to formula, number of mole is equal to mass number of molecule divided by 6.023 into 10 to the power 23. You studied already. So on this basis you find out number of molecule. So number of molecule is equal to number of moles 0.002 into Avogadro number 0.62 into 10 to the power 23, means here 12.02046 into 10 to the power 20, get it answer 20, it's a final answer. Okay, that's why options third one is a correct here. This is number of molecules. Next question. Here vapor pressures of the carbon tetrachloride at 25 degrees centigrade is 143 millimeters of a mercury. 0.5 gram of non-volatile solute of molecular weight 65 is dissolved in 100 ml of CCl4. Find out the vapor pressure of the solutions. Here formula P naught minus P divided by P naught is equal to W2 M2 W1 into M1. Here vapor pressure of the carbon tetrachloride is given 143 Kelvin. Vapor pressure solution find out here. This one once again 143. Okay, what's the weight of the solute here? 0.5 gram of non-volatile solute. 0.5. Okay. Then what's the molecular weight of this one here? 65. Next, W1, weight of the solvent. Okay, W1 is dissolved 100 ml of CCl4. So now weight of the solvent find out here. So weight of the solvent, we know density is given. So density is equal to mass by volume. Mass by volume or weight by volume is correct. Weight by volume. So weight of the solvent is equal to density into volume. Density into volume. What's the density here given? Density is a 1.58. Volume is equal to the volume 100 ml. Okay, so answer is 158. Get it? 158 gram. This is the weight of the solvent. 158 gram. So next, what's the molecular weight? It's a carbon tetrafluoride now. CCl4 is a given now. So here, this is a 35.2. That molecular mass of this one, 35.2. Here 71 means 142 carbon tetrachloride plus 12. So 415, 154 is the 154. This is the molecular weight of the CCl4. Okay, then you have to solve this one. P value find out here, sir. Okay, vapor pressure solutions find out here. We simplify this one. The final answer, this one you get it, 141. 1.43 it will get final answer. This is the option. Fourth one is the correct here. Okay. So next question. Okay, next one. The vapor pressure of the solution is directly proportional to the mole fraction of the solvent, inversely proportional to the mole fraction of the solute, inversely proportional to the mole fraction of the solvent, directly proportional to the mole fraction of solvent. Actually, vapor pressure of solution always proportional to directly proportional to mole fraction of solvent. Because when non-volatile solute is added to the solvent, the non-volatile solute occupy the surface of the solutions. Okay, in such a case, vapor pressure of the solvent solution directly proportional to the mole fraction of the solvent. Okay, when mole fraction of the solvent goes on increases, the vapor pressure solutions also increases. So fourth one is correct here. So next question, which of the following maximum vapor pressure at 300 Kelvin? Here we know that vapor pressure is a maximum. We know that delta P divided by P naught is equal to I into N2 divided by N1. This is the formula. Means as the I value increases, delta Tp also increases. But delta Tb is equal to P minus vapor pressure pure solvent minus P. Difference between the vapor pressure pure solvent and solute delta Tb. The vapor pressure solution P is equal to P naught minus I into delta P. So this value goes on increases. This value goes, when I is increases, this value means I into delta P also increases. That time whatever the vapor pressure solution goes on decreases. As I value increases, here go for the sodium chloride. Sodium chloride I value is equal to 2. Okay. Then if you go for the acetic acid partially dissociated. That's why its I value is also 2. Sodium chloride again 1 molar sodium chloride I value 2, but here it is not completely dissociated. Here I value 1. So in which case I value is a minimum actually. So this case, third case. That's why which one shows the maximum vapor pressure? So this one is correct because I value less here. Remaining case I value is more. That's why option third one is correct here. Next one. Benzene and toluene, nearly ideal solution. At 20 degrees centigrade, vapor pressure of the benzene is 75 torr and that of toluene is 20. The partial vapor pressure of benzene is 20 degree. At 20 degree, for the solution contains 78 gram benzene and 40 gram of the toluene. Here question is the partial vapor pressure of the benzene. Partial vapor pressure of benzene is equal to partial vapor pressure of benzene is a pure solvent, pure state into mole fraction of the benzene. It's a formula. Mole fraction of benzene. Okay, here partial vapor pressure of the benzene is given. What is the partial pressure vapor pressure? Partial vapor pressure of the benzene. at 75 tau is a given into mole fraction of benzene is a find out. So mole fraction of benzene, because they given mole fraction of benzene, you know formula, benzene is a number of moles of benzene divided by number of moles of benzene plus number of moles of a toluene. So 75 into number of moles of benzene is find out here. So benzene 78 gram is a given. 78 divided by 78, molecular mass of benzene 78. Here 78 divided by 78. Okay, plus number of moles of a toluene. So 46 divided by 92, molecular mass of this one. Okay, we simplify this one. So it will be cancelled here. So this is a 1 za, 2 za. So 75 into 1 by 1 plus 1 by 2. So here 75, okay, 75 into, so here if you simplify here 1 by 3 by 2, or I can write 2 by 3. Okay, 2 by 3. So we can simplify this one. So 150 divided by 3 means 50. 3 ones are 3, 5 is 15, 3, 50. So answer is a 50. That means the answer is the fourth one is the correct here. So next problem. When substance is dissolved, the vapor pressure of the solvent decreases. So this result is vapor, when substance is dissolved in solvent, vapor pressure of solvent decreases. Automatically boiling point of solution goes on increases. Here result is solution having a lower osmotic pressure than solvent, no. Decreasing the boiling point, no. Increasing here. The solution having higher freezing point than solvent, increasing the boiling point of solution. Options fourth one correct. When solvent is added, vapor pressure solutions decreases, boiling point of solution goes on increases. That's why fourth option is here correct. Next one, vapor pressure of the pure liquid A is 0.80 atmosphere. On mixing non-volatile solute B to A, its vapor pressure becomes 0.6. Mole fraction of the B. It's a direct questions here. So P naught minus P divided by P naught is equal to mole fraction of the B solute. Actually B is a solute here. So vapor pressure pure solvent is 0.80 minus, on mixing non-volatile solute B to vapor pressure becomes 0.6. Vapor pressure solution become 0.6. Here 0.80 is equal to mole fraction of the B solute. So now simplify here. Here 0.2 get it. Here 0.8 is equal to mole fraction of the solute. So means 1 by 4 is equal to B. Means it implies that 0.25 is the correct options. Options third one is correct here. So next question. The vapor pressures of the two liquid P and Q are 80 and 60 respectively. The total vapor pressure of solution obtained by mixing 3 mole of P and 2 mole of Q would be the vapor pressure of the two liquids is given. You know, total vapor pressure is equal to vapor pressures of the A, solvent A, or here I take it as a P into mole fractions of the P plus partial pressure of the Q into mole fraction of the Q. So partial pressures of the P is given 80, okay, 80 into mole fraction find out. So mole fractions of the P 3 divided by 5 plus this one is 60 into here 2 by 5. Okay, so then you have to simplify this one. So 5 ones are 5 ones are 360. So this means 48 plus 5 ones are 5 ones are here 12 into 2 24. Okay, so for 272 is the answer here. Options first one is a correct here. So next question, which of the following is a maximum vapor pressure? Actually in this case maximum vapor pressure HI, because bond becomes weak between the hydrogen and halide, the vapor pressure becomes increases. That's why HI is the maximum vapor pressures. Next question, for a dilute solution, Raoult's law states that for a dilute solution, Raoult's law, you know that relative lowering vapor pressure produced by the dissolving non-volatile solute is equal to the mole fraction of the solute. It's a statement. So correct statement, lowering vapor pressure is equal to mole fraction of the lowering vapor pressure is equal to mole fraction of solute. Relate to lowering vapor pressure is equal to proportional to the amount of solute in the solution. Relate to lowering vapor pressure equal to the mole fraction solute. Vapor pressure solution was equal to the mole fraction solvent. So option third one, relate to lowering vapor pressure is equal to the mole fraction of the solute. It's a statement of the Raoult's law. Next, a dry air is passed through the solution containing 10 gram of solute, 90 gram of water, and then it passes through the pure water. Then there is a depression in the weight of the solution by 2.5 gram, and in the weight of the pure solvent 0.05 gram. Calculate the molecular weight of the solute. So this is based on the Ostwald-Walker methods. We studied already Ostwald-Walker method. In the Ostwald-Walker method, there are two set of bulbs are there. The first set of bulb is filled with a solution. Second set of bulb is filled with a pure solvent. Okay, this is a pure solvent. Then it's connected to the U tubes. Okay, this is U tube. Now in this case, so okay, it's filled with the calcium chloride, no problem. Here see, this is a filled with the solutions filled in this set of bulb. Here pure solvent is filled here. This is a pure solvent. Okay, first actually pure and dry air. First of all, weight of the solution bulb and pure weight of the solvent bulb is determined, and U tube also determined. Afterwards, pure and dry air is passed through it. So now this vapors absorbs the air. Actually, air is passed now here. The air absorbs the vapors from the solution, then passed through the same pure solvent. Here also vapor is absorbed by the pure solvent. Then it's passed into the U tube containing calcium chloride. But calcium chloride absorbs all the vapors from the air. As the result, mass of this one increases. Mass of these two set of bulbs goes on decreases. Okay, so that's why the loss in the mass of the solution bulb directly proportional to the P. Okay, so loss in mass of solution bulbs. Okay, solution bulbs directly proportional to P. Similarly, loss in mass of solvent bulbs proportional to P naught minus P. P naught is the vapor pressure pure solvent, minus P, because air is first passed through the solution, then passed into the pure solvent. That's the P naught minus P. Total loss is equal to P plus P naught minus P. So here minus P plus P cancelled here is equal to P naught. Okay, P naught is equal to increasing the mass of U tube. Increase in mass of U tube. Increase the mass of U tube. Okay. So now here, what's here written here? What's given here? A dry air passed through the solution contain 10 gram of solute, 90 gram of water, and then passed through the pure water. There is a depression in the weight of the solution bulb is 2.5, and weight of pure solvent by 0.05. So now formula P naught minus P divided by P naught is equal to W2 divided by M2 into W1 divided by M1. Here P naught minus P, loss in the mass of the pure solvent, equal to 0.05. P naught, loss in the mass of this one, 2.5. Okay, is equal to, what's the weight of the solute here? 10. Molecular mass is a find out, M2 find out. What's the weight of the solvent? Okay, here, so here M1. Okay, here W1. What's the weight of the solvent? Solvent 90. This one is 18. Water. If you simplify, 18 ones are, this is a 5 user. Okay, so M2 find out here. M2 is equal to for the same molar concentration, concentrations are the same. For sucrose, elevation of boiling point, delta TB is equal to M into Kb. Okay, or delta TB directly proportional to the molality. Or I can write here I into M, molality. Okay, for a boiling point sucrose solution, so delta TB sucrose solution is equal to 0.1 degree because it not dissociate, I value is equal to 1. But in the case of sodium chloride, I value is at 2 now. Therefore, delta TB directly proportional to 2 into 0.1. Okay. So elevation of boiling point is a given. Here, what is elevation of boiling point here? Elevation of boiling point to sucrose is 0.1. Okay, here 0.1. This here 0.1. Here I into M, but I value is a 1 here. But in this case, I value, what's I value here? 2. It's a number of molecules. I value 2 into M. Okay, so I value equal to 2 means what is this value becomes doubles 0.2. Okay, delta TB it becomes doubles, so 0.2 is a correct. So options third one is a correct. Next one, when 10 gram of non-volatile solute is dissolved in 100 gram of benzene, it raises the boiling point by 1 degree. Then molecular mass of the solute is 10 gram of non-volatile solute is dissolved in a 10 gram of it's dissolved in a 100 gram of benzene. It rises boiling point 1 degree. So molecular mass. So delta TB is equal to 1000 into Kb into W2 divided by M2 into W1. Elevation in the rises in the boiling point is 1000 into Kb 2.53. Weight of the solute 10 divided by molecular mass of the solute. You have to find out weight of the solvent. Okay, molecular weight. What's the solvent here? 10 gram of non-volatile solute dissolved 100 gram of benzene. Okay, here actually the weight of the solute 100 gram. Correct. This 100 gram of benzene. Weight of the solvent is 100 gram. It rises by then molecular mass. So what's the weight of the? Okay, here. Okay, weight of the solute. Okay, here what's the weight of the solute? Sorry, 10. Correct. Yeah, this is 100 gram. It's a given already. So then you simplify M2. M2 is equal to 1000 into 2.53 into 10 divided by the 100. 1s are 10s are. So means 253 grams answer. Okay, options first one is a correct here. Next, at higher altitude, the boiling point of water is lowest because boiling point is the boiling point of water is lower. Actually, what is the boiling point? The temperature at which vapor pressure of the solution become equal to atmosphere pressure. Boiling point of the water is lower means atmosphere pressure is lower. That's why atmosphere pressure very high, temperature is low, the atmosphere pressure is low, none of this one. Third one, atmosphere pressure is low. So what is the boiling point definition? Boiling point is the temperature at which vapor pressure become equal to atmosphere pressure. Atmosphere pressure low means automatically boiling point of the solvent is also low. That's why atmosphere pressure is low. That's the third option is here correct. Thank you.